Hi students, today we are going to see about the revision for 4th and 5th chapter. That is the 4th chapter, electromagnetic induction and alternating current. And in that, so what is electromagnetic induction? Then magnetic flux. Magnetic flux is the same definition as electric flux, that is the number of magnetic field lines passing through that area normally, and is given by the equation phi. You have to write phi b is equal to integration over the area b vector dot dA vector. So magnetic flux equation. And next you are having Faraday's experiments, that is how the magnetic field is induced, and because of that there is a change in magnetic flux and the EMF is generated, that is shown by Faraday's experiments. And there are two part of the experiment. And next we shall see about Lenz's law. Lenz's law states that the direction of the induced current is such that it always opposes the cause responsible for its production. That is, we are going to find out the direction of induced current using Lenz's law. So the direction of induced current will always oppose the cause that is responsible for the production. That is about Lenz's law. And here these are only the experiments. And next we are going to see about motional EMF from Lorentz force. And you know already Lorentz force, FB vector is equal to minus E into V vector cross B vector. This is for a single electron, and you have to find out the EMF from this derivation, that is E is equal to BLV. This E is equal to BLV is nothing but motional EMF. And next, eddy currents. So eddy means whirlpool, that is circular form of currents. These eddy currents, how they are formed, and you have to read the definition, that is what are called Foucault currents or eddy currents, and there is one demonstration for that. And there are 4 examples given for the application of eddy currents: induction stove, eddy current brake, eddy current testing, electromagnetic damping, etc. And you have to read every one. And self induction, suppose you are having a single coil, and if there is a change in EMF and if there is a change in magnetic flux, EMF is induced. If it is having a single coil, it is called self induction. If you are having 2 coils, then it is called a mutual inductance. And you have to define what is self inductance and physical significance of inductance. And so this is self inductance of a long solenoid. This is a 3-mark question. So you have to derive the equation for L. So L is obtained as mu naught mu r n square AL. So this is about self induction. Then mutual induction means you are having 2 coils. They are mutually inducing the EMF. This is the first left hand side part is called secondary coil, and the right hand side part is called left hand side primary coil and right hand side secondary coil. And suppose if you give an EMF here in the primary coil, another EMF is induced in the secondary coil. Here also you are deriving mutual inductance. So this is for mutual inductance between 2 long coaxial solenoids. So 2 solenoids are placed one over the other, and you are going to find out mutual inductance in that. So you are having several problems relating to this self inductance and mutual inductance. So here you are having a problem to find out L. If you know the formula for L, you can substitute and find out. L is mu naught mu r n square pi r square by L. So substituting this formula, you can find out L, and the unit for inductance is Henry. So you have to read all the problems relating self inductance and mutual inductance. And so next we are going to see about methods of producing induced EMF. And you have already seen there are 3 methods for producing induced EMF. This is a 3-mark question. How can you get the EMF? By changing magnetic field, by changing area, and by changing the relative orientation of the coil with respect to the magnetic field. So there are examples given for finding out this. Next, AC generator. So an EMF is induced using this principle, that is called AC generator, and so here the principle is electromagnetic induction, and the working of AC generator is given. So these are the diagrams to explain AC generator. This is a 3-phase AC generator where you are getting 3 EMFs. Next, transformer. What is a transformer? It is used to transform electrical power from one circuit to another circuit without changing the frequency. So next, construction working of a transformer, and several energy losses are in transformer that you have to read. And what are the advantages of AC in long distance power transmission? Usually for long distance power transmission we are only using AC because it is there are no power loss in AC transmission, so this is preferred more. So these are the advantages. And next, AC. In AC we are having resistive circuit, inductive circuit and capacitive circuit. So mean or average value of AC, that you have to read the definition for average value of alternating current and RMS value of AC. And you are having different phase diagrams, and there are 3 parts in this: AC circuit containing pure resistor, and the next one is AC circuit containing only an inductor. This is otherwise called as inductive circuit. Here the AC is connected with the inductor, and so an EMF is induced in the inductor. So here you know V is equal to V naught sine omega t, and EMF, because of this an EMF is induced, which is given by E is equal to minus L into di by dt. You are equating these two equations and find out I. So I is found to be lagging behind voltage. In inductive circuit usually voltage is leading. You see this diagram, the red arrow shows the voltage, and voltage current is lagging by an angle of pi by 2. So the red represents voltage and the green represent current. So here you can see from the diagram the voltage leads in inductive circuit. So here also usually the red graph is for voltage and green graph is for current. And so here the final equation is I is equal to Im sin omega t minus pi by 2, because it is lagging behind the voltage. And XL you have to find out the formula for XL. So XL is 2 pi FL. So this is very important formula, and for a steady current the frequency is 0. So the capacitive reactance is also 0. So next, AC circuit containing only capacitor. So instead of inductor you are having the capacitor, and in this capacitor current leads. So here you see the current is shown with a green arrow, and here the current leads the voltage. Current first comes and then the voltage. So for inductive circuit voltage leads, and for capacitive circuit current leads. And here the 3 components, resistor, inductor and capacitor, they are connected in series, and we are finding out the phase diagram for that. Then resonance. Resonance is very very important for radio, TV, etc. So you have to find out next the definition for Q factor. So it is defined as a ratio of voltage across L or C at resonance to the applied voltage. So you have to divide voltage across L or C at resonance to the applied voltage. And so this is about Q factor. And advantages of AC over DC. The first advantage is AC generation is very cheap, and AC can supply very higher voltage. Also the transmission losses are very very less. AC can easily be converted into DC. These are the advantages. And what are disadvantages? So alternating voltage cannot be applied for all the applications. Example, for charging of batteries, electroplating, electrotraction, etc. And at high voltages it is more dangerous, because AC is usually attractive, whereas DC is not attractive. So it is very dangerous to work in AC in high voltages. Next, oscillation in electrical circuits. So conservation of energy in LC oscillations. So that's all, this chapter is over. Next we are going to see about the fifth chapter, and here this is about electromagnetic waves, and you have to define what is electromagnetic wave, and displacement current, and Maxwell's correction to Ampere circuital law. And there are some equations, Maxwell's equations integral form. So there are 4 equations in integral form, and so this is the first equation, that is Gauss law in electricity, and the second equation is Gauss law for magnetism. So this is for electricity and this is for magnetism, and in the first equation E vector, the second equation B vector. Here Q enclosed by epsilon naught, right hand side, here it is 0. And so next third equation, which is Faraday's law, and the fifth equation is Ampere Maxwell law. So these are the integral form of Maxwell's equation. So you have to read these 4 equations. Next, what is an electromagnetic wave? It is a non-mechanical wave which move with the speed of light, and the properties you have to study. They are very easy properties, and the about 8 points are there. So the 8 points are very easy points. So you have to read all the properties of electromagnetic waves and the sources of electromagnetic waves. And here you are having 7 types of waves. You have to read the uses of each and every wave: radio wave, microwave, infrared radiation, visible light, ultraviolet radiation, X-rays, etc. And next comes types of spectrum. There are 2 types, emission and absorption spectrum, and Fraunhofer lines. And you have already read about emission spectra. Also prepare absorption spectra and what are Fraunhofer lines. So that is the end of this chapter. So all the best girls, prepare well and write the test.